Oxygen in the atmosphere consists mostly of stable O2 molecules composed of 2 oxygen atoms. Oxygen can also exist as the less stable O3 molecule composed of 3 oxygen atoms, called ozone. Ozone is present in both the stratosphere, Earth's upper atmosphere, and at ground level. At ground level, ozone levels are about 0.1 parts per million. Accumulation of higher levels of ozone, resulting from some human activities, is harmful. Levels of ozone in the upper atmosphere are much higher, ranging from 2 to 8 parts per million. Here, ozone plays a crucial role in protecting life by absorbing the majority of the sun's harmful ultraviolet UV radiation. This protective layer, commonly referred to as the ozone layer, is situated approximately 10 to 30 kilometers above the Earth's surface. The ozone layer acts as a shield, absorbing and scattering the sun's UV rays, particularly UVB radiation, which is the most harmful to living organisms. Without this layer, higher levels of UVB would reach the Earth, leading to an increase in skin cancers, cataracts, and other health issues in humans, as well as negatively impacting marine ecosystems and terrestrial animal and plant life. In the mid-20th century, scientists discovered that certain human-made chemicals, particularly chlorofluorocarbons, CFCs, were causing significant damage to the ozone layer. Due to their stability and non-flammability, CFCs were at the time widely popular for refrigeration, air conditioning, foam blowing, and as propellants in aerosol sprays. However, this stability also meant that CFCs could persist in the atmosphere for a long time. Once they reached the stratosphere, they were broken down by UV radiation, releasing chlorine atoms. These chlorine atoms then reacted with ozone molecules, causing the ozone to break apart. This reaction cycle could repeat itself many times, with one chlorine atom capable of destroying thousands of ozone molecules. This process led to a thinning of the ozone layer, most notably observed as the ozone hole over Antarctica, which was first discovered in the 1980s. The recognition of the ozone depletion problem spurred international scientific and political actions. The Montreal Protocol on substances that deplete the ozone layer in 1987 was a landmark international treaty aimed at phasing out the production and consumption of ozone-depleting substances. The Montreal Protocol was unique in its widespread acceptance and implementation, ratified by all member countries of the United Nations. The protocol established legally binding reduction targets for CFCs, with developed countries taking the lead and providing financial and technical assistance to developing countries. The impact of the Montreal Protocol has been profound. Since its implementation, the production and use of CFCs has declined by more than 99%. As a result, their levels have been decreasing and the ozone layer started to recover. While complete recovery of the ozone layer is expected to take several more decades, the protocol has successfully mitigated further damage and set the stage for eventual restoration. The story of the ozone layer and the well-coordinated response to its depletion serve as a powerful example of how international cooperation, underpinned by scientific research and flexible policy frameworks, can address global environmental challenges. This success inspires and informs efforts to tackle other environmental issues, such as climate change, demonstrating that with global commitment and collaboration, progress can be made in protecting the planet and ensuring the well-being of future generations.